Java slides about a stack from the textbook. And they give, I'm not going to go through all of these slides, but there's a couple of interesting slides that I think it's worthwhile mentioning. The first is just a reminder about the ADT acronym, right? ADT stands for Abstract Data Type. And the example they give on this slide is kind of interesting, right? If we want to buy or sell stocks, then we usually have to give the stock type, the number of shares we want to buy or sell, and the price we're willing to accept or receive. And you could think of this as a stack for trading stocks. I think it's a little bit of a stretch personally, because you probably have to have a separate stack per stock, because if you want to buy IBM shares, you're not going to accept Apple shares as the in return, right? So the buy and the sell conditions maybe need to be checked, which may mean different stacks. And here's the methods that we talked about, right? And I hadn't realized what this was until just now, right? This little icon up the top is a little Pez dispenser. If you don't know what Pez is, you're probably not from Connecticut. I'm not from Connecticut. But Pez is a little treat or sweet that comes in these little sometimes animal-headed holders, and they're spring-loaded, right? And you pull the animal's head back, and one of the little sweets pops out. So that's a perfect example of a stack, right? And here are the two, like I said in one of the previous videos, the two main operations you need to do on a stack is to push an object onto the stack and pop an object off the stack, right? And then there's some other potential methods. Top, or sometimes called peek, looks at the top element or the last element that was inserted into the stack without removing it from the stack. And maybe you need to know the size of the stack, how many elements are stored, and they're using the correct nomenclature for the method that tells you whether the stack is empty or not. Now, one thing that I haven't gone through much with you is generics, right? Or sometimes called templates. And this example here, this definition of a stack, uses generic notation. And the generic notation is this piece here, where we've got a less than sign, an identifier, and a greater than sign. And where the way generics are used is in allowing us to define, in this case it's an interface, but you can also use it in the class, is to define an algorithm on any class, really. In this case, there are no constraints put on the class. So we could put as E any class, right? And the names that this is called is sometimes generic. It's certainly generic in C++, in C sharp, and I believe it's also called generic in Java. In C++, the naming is a bit different. It's a template, and the idea is that you can make a stack of students, right, by just doing that, or you could make a stack of professors doing that. Okay, and the E in the statement is some sort of an object. Like I said, in this case, just about any, I think any class will work. Sometimes, if you have to have constraints on the class E, right? So if you, for example, wanted to have a sorting template or sorting there's a constraint on E that it needs to be ordered. So if we have E1, we need to know that we can tell whether it's greater than E2. Otherwise, we have no way of sorting it. Okay? So that's a thing about, particularly for some algorithms like sorting or finding the maximum. For finding a maximum, you also need to have a comparison operator, right? So you need to have this comparison operator defined for the class, and some classes don't have things like that defined. For example, how would you define it for the student class? How am I likely to want to sort students? I could want to sort students by their stag ID, or I could want to sort students by their family name alphabetically, or I could want to sort students by their GPA, right? So these things need to be thought of when you use generics or templates in that sort of way. Okay, let's see what else. There's an example. I'm not going to go through the example. This is the other big piece about that I talked about during some of the classes. Right? And the question is, when you come across a situation that's an error condition, what do you do? And there's two trains of thought, right? And the example they give is, what do you do when you pop an empty stack? You try and get an element off the stack, right? So one possible way is, right, if I get my let's just say we had a student stack, and we did student stack dot pop, and let's say the student stack was empty, right? And we decided to take the option that when we do a student stack dot pop on an empty stack, that that returns a null, right? If the next thing we do in the code is student dot I don't know, increase grade right? And we've popped a null off the stack, this is going to give me an exception, right? It's going to give me a null pointer exception. Or at least it's going to give you an error because of that student value being null, because null doesn't have a method called increase grade. So what the slides are suggesting is the other way to handle that popping an empty stack is to throw an exception. And that is also a valid way to deal with the issue. And I talked about in class, I've worked on code where we've done a bit of both, right? The issue with throwing an exception in the instances I'm thinking of is that the exception slows down the process, right? Throwing an exception is kind of like an abrupt change in the program, and it can slow down what you're trying to do. So in the instances I'm thinking of, we tried to have a clear split between where we dealt with the possibility of a null, right? We could, in this instance, right, if we decided not to throw an exception, what we could do is we could do if a student is not equal to null, right, we could protect the next call so that we didn't throw the null pointer exception. In general, it's better to throw an appropriate exception than it is to assume that every piece of calling code will deal with null value returns appropriately. Let's just have a quick look through. I think there was some examples. I did want to talk about this, but I'm going to